second part of solving equations involving base e or the natural logs. Is what if we have the natural log of something with an x on it? How do we solve? How do we solve for x? Okay, so I know that I'm going to need to separate this logarithm, right? So I need to put this back into exponential form. So before I do that, I need to just have the natural log by itself. So I've got to get rid of the times 3. So since it's just an equation, I can just divide both sides by 3 and get the natural log of 4x, and then 24 divided by 3 is 8. And if you say, wait, Ellis, why didn't we use the power rule and raise it to the third power? And I'll tell you, you can do that. It's a terrible idea though. All right, we'll come back at the end. We'll see what happens if you do that, but don't do that today. All right, so natural log of 4x equals 8. So I want to rewrite that in exponential form. So again, I'll do this in 2 steps just in case you weren't here before. The natural log is another way of saying log base e of 4x equals 8, which means if I want to write this in exponential form, so this is log base e, that means it's going to be e to the, and then 4x and 8 will switch places, so e to the 8th power equals 4x. Okay, and then again, we want to get x by itself, so I need to get rid of this times 4. So I divide both sides by 4, and I get, I can scroll down here, x equals e to the 8th power divided by 4. And remember, e isn't a variable. E has a value, 2.719 whatever. So what we do here is we go to our calculator, so go to Desmos or whatever we're using, and we just type in the letter e. And you notice that, yes, what's up? Okay, good talk. All right, what was I saying? So e is a value, 2.718, sorry. And we said it was e to the 8th power divided by, oops, make sure cursor's in the right place, divided by 4. And we'll get an, well, not exact, because e is an irrational number, but close enough that we can round it off. These are multiple choice. So you pick the answer closest to 745 point, all that, right? Okay, there you go. That's all it is. So let's try one more, in case that went kind of quick. So what is 5 natural log of 6x equals 8, solve for x? So again, same thing. We want to get the natural log by itself, so I need to get rid of this times 5, so I divide both sides by 5. So that is the natural log of 6x. And I could make this a decimal, but whatever, I'm going to leave it. I'm going to say this is just 8/5. Right? I have to put this in the calculator anyway. What do I care? So I rewrite this exponential form. So this is going to be e, we'll skip steps, e to the 8th bits power, which I know looks terrible, but it's okay, equals 6x, right? E is our base. We switch the 2 values. To get x by itself, we divide both sides by 6, and we get x equals, sorry, e to the 8th bits power all over 6. Oof, right? That looks bad, but again, we have a calculator to solve this. Let's put it to use. So e raised to the 8/5 power divided by 6. And we get 0.8255. Right? So not too bad, right? So you get your log by itself, rewrite it in exponential form, get x by itself, and then take that value once x is isolated, put it in the calculator, you get your answer. Okay, so I said I would go back to this one. What if, in an alternate universe, we use our power rule? So I'm going to erase all this work. I'm going to leave the final answer so we can compare the two. So if I use the power rule, I say, since I have a coefficient of 3, I can put that up in my exponent and say this is the natural log of 4x to the 3rd power. Okay, it's important to put that in parentheses here. Equals 24. So now the natural log is all by itself. I can rewrite it exponential form. So it's going to be e to the 24th power equals 4x cubed. Okay. So again, we want to get x by itself. So I need to get rid of this cube first, right? Because it's outside the parentheses. So the opposite of cubing a number is to take the cube root. So I'll take the cube root of both sides here. So that is the cube root of e to the 24th power equals 4x. And then I would divide both sides by 4. So I get x equals the cube root of e to the 24th all over 4. Which looks terrible, right? And that's not even a bad exponent, right? That's just a cube root. That has a name. Imagine if this was like 8. So then I go to the calculator and I say, what is nth root? It's a cute shortcut you can do on Desmos. So the cube root, where did I write this down? Of e to the 24th power, all divided by 4. And we notice we get 754. It's the exact answer we had before. But if I said, what would you rather have to type into the calculator, e to the 8th over 4, or the cube root of e to the 24th divided by 4? And you'd be like, wait, this is way simpler. So even though you can use the power rule for these, I would not recommend it, right? It's just extra work. It's a lot easier just to divide by 3 than to have to carry around this cube root throughout the entire process. Okay? All right, that's all. So good luck. Let me know if you have any trouble.